In this video, we're going to answer a question, how big is an Angry Bird? When playing Angry Birds, what you really notice is that an Angry Bird hits hard. So it can knock down a pig, in this case it just spontaneously combusts, and it knocks down cement and wood, and it can knock down buildings. So what we're going to do here is ask, how big is an Angry Bird, and how much does it weigh? Okay, so to calculate how big a bird is, we're going to use conservation of momentum, which was put forward by Isaac Newton. We're going to need scale. We need to measure the size of an angry bird, and also velocities, which are how fast things move. So how big are these objects? How big is red? How much does how much does the cement and this wood weigh for it to be knocked down? It turns out that objects fall at the same rate independent of weight. That is, if you were to go at the top of a building and drop a penny versus a 10-pound weight, they should fall at the same rate. And this was shown by Galileo. And this is the equation for falling objects that he deduced. Distance equals 1/2 times acceleration times time squared. And if you're on Earth, acceleration is gravity pulling things down, and that's 9.8 meters per second squared. So we're going to just put 1 second in for time, and if you put 1 second in, this tells you that objects should fall 4.9 meters in 1 second. Okay, so we're just going to watch a bird fall. This is a really, simple video. I'm just throwing the bird, hitting nothing. And if you replay this video, when it's at its peak, gravity will now bring the bird down, and you look 1 second later from when it's at its peak, and it's fallen here 4.9 meters. So I know that this distance from the peak to where it's fallen is 4.9 meters. And I have this little ruler that I have, and since I know that objects fall 4.9 meters in 1 second, and this ruler has 32 ticks on it, it shows me that 4.9 meters in 32 ticks, and that is 0.15 meter per tick. So I'm going to use this ruler in the rest of my slides to measure things. So for example, now I can just focus on and measure red, and red's height is 6 ticks, and because we know each tick is 0.15 meter, then we know that red's height is 0.9 meters or 3 feet, and similarly red's width is 0.75 meters or 2.4 feet. So we can also measure the stone height that the pig is sitting on, and the wood height and the wood length. Okay, so angry birds are 0.9 meters or 3 feet across, and 0.7 meters or 2.4 feet in height. And I took this picture off the web, and this is a picture of the Angry Birds theme park in China, and this is about the approximate size of what you play in the video game. So if an Angry Bird were to be here in real life, it would be this size. This is to scale. Okay, so let's now watch the hit, and we're going to calculate the weight with this. This is conservation of momentum that we're looking at, because we want to calculate weight. And I played this game several times, and what you saw is I actually did not hit the, let me just play that again. I'm going to use this movie for the next couple of calculations, and in this you can see that I actually don't hit the pig, I hit the wood, and the wood and the cement falls, and finally the pig explodes. Okay, so conservation of momentum. What we're going to do is we're going to measure what red's velocity is coming in versus out of the hit. So this is the momentum before the collision, which is the red Angry Bird's mass times velocity, and the momentum after collision, which is how fast the bird is moving after the collision, as well as now, because I've hit the wood and the cement, the mass and velocity of the cement stand. It turns out the pig doesn't actually move. Okay, so first we're going to calculate the mass of the cement stand. So to calculate the mass of the cement stand, we need to know the volume of these items, and we know it because we measured it from before. So the volume of the wood is length times width times height, and that was measured before. And so plugging those numbers in, we find it's 0.16 meters cubed. Now the mass of wood is volume times density, and just looking up pine density on this website, engineeringtoolbox.com, you learn that pine's density is 500 kilograms per meters cubed. So we're just going to plug that in. We have the volume times the density, and now we know that the mass of the wood is 81 kilograms, or about 180 pounds. Similarly, we're going to do this for concrete, and we're going to assume this is a concrete column, and we've measured it before. We calculate the volume to be 0.25 meters cubed. Granite has a density of 27 kilograms per meters cubed, quite dense, as you would expect, and so now the mass of this concrete column is 590 kilograms, or 1,300 pounds. And so this total mass is about 670 kilograms. Okay, so now we figured out the mass of this concrete stand as being 670 kilograms. So now we're going to figure out the velocity of the red bird coming in before the collision. And you can see the movie playing here. And what we do is we just count how fast red travels frame by frame. So each frame is about 0.05 seconds, and we measure that red moves 2 ticks per frame. So that's 0.3 meters per 0.05 seconds, or 6 meters per second. Okay, so now we figured out the velocity before the collision as 6 meters per second. And now we're going to measure the velocity of red after the collision, and also how fast this concrete and stone moves. Okay, that was just a quick movie after the collision. And what we do is we put a point of reference here, and then we look at the following frames, and we see how fast does red move, as well as how fast does this concrete and wood stand move relative to the center of gravity. So the bird's velocity is 1 tick per 1 frame, which is 3 meters per second, and the platform velocity measured from the center of mass here is 2 meters per second. Okay, so now we can plug these in. We'll do that. And now we can solve for the mass of a red bird. And we solve for it, and the mass of a red bird is 447 kilograms, or 985 pounds. So let's just do a sanity check. That's half a ton. Okay, so mass of a red bird is 447 kilograms. Does that make sense? It's half a ton, but on the other hand, it's a big bird, as I've shown you what the metrics are. So the volume of red is 4/3 pi r cubed if we assume that it's a sphere, and we already measured its dimensions before, so we'll just assume the volume is 0.38 meters cubed. So now that we have volume and mass, we can calculate the density of this bird, and the density turns out to be 1171 kilograms per meters cubed. Okay, it turns out that average human body density is 1,062 kilograms per meters cubed. So actually the density of an angry bird is very similar to a human body, is very similar to the density of a human body. So it's just this really big mass of flesh and blood. It's not like a big concrete ball. It's just a big spherical blob of flesh. Okay. In conclusion, an angry bird weighs about half a ton, 1,000 pounds, and its size is about 0.75 to 0.9 meters.